Okay, so we've been talking about graphing and linear equations. So we are actually going to be talking about slope today, and this is chapter 8.4. And slope is a very important part of graphing, and it's actually kind of a shortcut to all this graphing that we've been doing. So I'll show you what we mean. Please take a moment to get these key concepts copied into your notes and replay me when you're ready for the explanation. Okay, so the first key concept we're going to talk about is the actual word slope. And slope describes the steepness of a line. It is the ratio of the rise to the run. So you can think of slope like your roof of your house. You know, you can have a really steep roof, or you could have maybe a not so steep roof. You can think of that line of your roof being really steep or maybe not as steep. These are all both uh, steepness of a line. Okay, so we look at slope, and it's the rise over the run. The rise describes the vertical change, and the run describes the horizontal change. Note that the slope is the same for any 2 points on a straight line. So the slope between this point and this point is going to be the same between this point and this point. It's going to have the same slope. Slope can also be positive. It can be negative, it can be 0, or it can be undefined. Now, I know we discussed a little bit about 0 and undefined before, but the difference between 0 and undefined. So when I have 0 over some kind of number, maybe let's say 3. 0 over 3. This equals 3. Oh my goodness, no it doesn't. It equals 0. My bad. And undefined has maybe a number over 0. And let's say that number maybe is 3. So 3 over 0. Now we can never have 0 in the denominator. So that is when it becomes undefined. Okay, so the difference between 0 and undefined is this undefined has a 0 in the denominator, where the 0 has the 0 in the numerator. That's important to remember. And how we find the slope in algebraically is this right here. We've got m equals y2 minus y1 over x2 minus x1. Okay, here's our first example. First of all, I want to talk to you a little bit about the positive and negative directions before we get into this example. So over here, I want you to make a little note. And whenever we move in the direction up, that makes it positive. Whenever we move in the direction down, we are going in the negative direction. Whenever we move right, we become positive. And whenever we move left, we are negative. So you'll want to make a note of this and remember these. Up is positive, right is positive, down is negative, left is negative. Okay, so let's look at this example here. So I want to find the slope of this line. All right, so I am starting here at this one point given to me. And I'm going to try and find how far away this point is here. What's the steepness of this line? So I'm going to go up 1. Remember, it's rise over run. So from here, I rose 1, or I rise 1. And then to get to this point right here, I'm going to run to the right 1, 2, 3. So I run 3. So my slope of this line right here is 1/3. Now I could also do this algebraically. Remember that formula I had y2 minus y1 over x2 minus x1? We can look at these points right here, and we can pick these as, let's say this one is x1, y1. This one's x2, y2, and you want to keep this, if you pick this one as your number 1, you want to keep these both consistent with number 1. And if you pick this one as your second one, you want to keep these consistent with your second. So let's plug in. Y2 is 3, y1 is 2, and x2 is 5, x1 is 2. So this is 3 minus 2 is 1, and 5 minus 2 is 3. As you can see, both algebraically and from the graph, we have the same answer. So our slope is 1/3. Okay, now I want you to try this example on your own and pause me while you work it out and replay me when you're ready for the answer. Okay, so first of all, you look at this problem, and we've got a point here, and we've got a point here. First of all, we need to rise, and we're going to rise down 1, 2, 3, 4. And when we go down, remember that's a negative. And we're going to go to the right, 1, 2. Okay, now this is a fraction, -4/2, but we always know that we got to give it in simplest form, so this is actually a slope of -2. Now, if we do this algebraically, we have y2 minus y1 over x2 minus x1. And we use maybe this one as our x1, y1. This is our x2, y2. And we can plug in -3 minus 1 over 0 minus a -2, which is +2. -1 minus 3. -3 minus 1 is -4 over 2, simplified is -2. Okay, now we're going to find the slope of these lines. Now the difference between this line and the lines we just saw prior is that they are a horizontal line and a vertical line. Now these are going to be the special cases of where we don't have, we have a 0 slope, or we're going to have an undefined slope. Now to tell the difference between these, I'm going to solve these algebraically. So this one will be x1, y1, x2, y2. I'm going to plug into m equals y2 minus y1 over x2 minus x1. And from here, y2 is 1 minus 1 over 3 minus a plus 1, or 3 minus a -1. And this is 0 over 4. Now 0 over 4 we talked about being 0. It has a 0 slope. So you can always remember that a horizontal line has a 0 slope. Well, let's look at what happens with a vertical line. So we have x1, y1, x2, y2. And we plug into our y2 minus y1 over x2 minus x1. And we have 6 minus 0 over -5 minus a -5, which is a +5. And we have 6 over 0. Now, whenever we have something divided by 0, remember we can never have it to 0 in the denominator. So this slope is undefined. So whenever you have a vertical line, know your slope is always going to be undefined. Okay, now sometimes you won't be given a graph, so we don't have the option of counting rise over run. So we actually only can use the algebraic form, which is m equals y2 minus y1 over x2 minus x1. And when you do this, you want to be always consistent with what you choose. So if we choose this one as our 1 and this one as our 2, both this x and y always have to be 1. And both this x and y always have to be 2. Okay, so this, I'll just go ahead and label it x1, y1, x2, y2. Now, honestly, it does not matter if you choose this one to be 2 and this one to be 1. It doesn't matter, but as long as you just keep yourself consistent. Okay, so I'm going to plug in here 4 minus a -3, which is +3, and 5 minus 1. We get 7/4. Now we can't simplify this any further, so that's going to be our slope of 7/4. Okay, now here's your turn. I'd like you to try this one as best you can and replay me when you're ready for the answer. Okay, so this one was x1, y1, x2, y2. We plug in 6 minus 6 over -1 minus 2. And this becomes plus minus 0 over -3. And 0 divided by -3 is 0. So this slope here is 0. Okay, now here are some practice problems for you to do. It starts at 5, but you can start, with 1, 2, and so on. But go ahead and give these your best shot, and we will go over them the next time we see each other. Good luck.